Okay, so we all know gravity pulls us down, right? But have you ever really stopped to think about why it works the way it does? Why it follows this one very specific mathematical rule? Well, today we're going to dive into a pretty wild idea. What if the inverse square law isn't really a law at all? What if it's just a message, a kind of code, written into the very fabric of space itself?
I mean, think about it. This is one of the most precise, fundamental rules in the entire universe. The strength of huge forces like gravity and even electromagnetism, they all fade with the inverse square of the distance. So, you double your distance from a star, and its gravity pulls on you 4 times less. Exactly 4. But why? Why that specific number? Why isn't it 3 times less, or maybe 5? It just seems so specific, doesn't it?
You really have to wonder, right? Couldn't the universe have been built differently? I mean, why not just a simple 1 over r relationship? Or maybe something that drops off way faster, like 1 over r cubed. The fact that nature chose or settled on exactly 1 over r squared, that feels like a clue. Like a big flashing arrow pointing to some deeper logic that we just haven't figured out yet. Okay, so that's where we're going to start our investigation today. Let's ask a different kind of question. What if the answer has nothing to do with the force of gravity at all? What if it's all about the geometric code of space itself? What if this inverse square law is just space, kind of telling us how it's put together? So let's try a little thought experiment together. I want you to just forget everything you think you know about gravity as a force. We're going to toss that idea out the window for a bit. Instead, we're going to build a model of space from the absolute ground up, using nothing but simple geometric rules. And then, we're just going to sit back and see what kind of scaling law naturally pops out. All right, so how do you build a universe from scratch? It sounds like a huge question, but according to this model we're exploring, it turns out you might only need 2 super fundamental geometric ingredients. That's it, just 2. First up, we've got something called a junctional sphere, or JS for short. Now, the best way to think about this is just like a single pixel of space. It's the absolute smallest, most basic piece of geometry you can imagine. Literally, you can't zoom in any further. This is the bottom floor.
Okay, so you have these individual pixels. What happens next? Well, they group together into these really stable structures called composite units, or SH. So if the JS cells are the pixels, you can think of these SH units as the Lego bricks of space. Each brick is built from a very specific number of pixels, and it's these bricks that start to give our universe its structure. And this is where it gets really cool, really elegant. These Lego bricks, they don't just float around all willy-nilly. Nope. They naturally organize themselves into these stable, concentric shells. The best analogy is just to picture the layers of an onion, right? Each one of those layers is a stable shell made up of these geometric building blocks. But, just knowing that space is built in layers like an onion, that's not quite enough to solve our big mystery. The real secret, the biggest clue of all, is hidden in the very specific mathematical rule that determines how these shells are actually spaced apart from each other. And this is our first major breakthrough. It turns out the geometry of this whole model isn't random in the slightest. As you move away from the center, it follows this really surprising, really specific pattern of growth. So on the one hand, you have what you might intuitively expect, just a simple linear growth. Shell number 2 is twice as far as shell number 1, shell 4 is twice as far as shell 2, simple. But that's not what happens here. Our geometric model follows a totally different rule. The distance, or the radius to any given shell, it doesn't grow with the shell number n, it grows with the square root of n. And that's weird. Okay, this is it. This relationship is the absolute cornerstone of this entire idea. I really want you to lock this one in. The distance to a shell is proportional to the square root of its shell number. That one kind of strange detail is about to solve the whole puzzle for us. All right, so we've got our first big clue, and it comes from this unique geometry of space. Now, for our second and final clue, we need to look at a universal principle, something that applies to pretty much everything that spreads out in our world. So for a second, let's just put our JS and SH units on the shelf. We're going to step away from that and talk about something way, way simpler. It's the idea of conservation. Basically, stuff doesn't just appear out of nowhere or vanish into thin air. So if you have a fixed amount of something, and that something spreads out, its concentration has to go down.
Makes sense, right? Let's make it super simple. Just think of a can of spray paint. You give it one quick puff. Pfft. That's it. The total amount of paint in that little cloud is now fixed. It's conserved. We're not adding any more paint.
So right when it leaves the nozzle, all that paint is crammed into a tiny little area, so its density is super high. But as that cloud expands and travels outward, that exact same amount of paint has to cover a much, much bigger area. So what happens? Its density naturally gets lower and lower and lower. It has to.
And here is the punchline. How does it spread out? In a sphere. And the surface area of a sphere grows with the square of its radius, r squared. So as our fixed little cloud of paint spreads out over this ever-expanding spherical surface, its density must decrease as 1 over r squared. There's no other way. It's just an unavoidable consequence of living in 3 dimensions.
And just like that, we have it. Our 2 essential clues are on the table. Clue number 1 came from our specific, kind of weird model of geometric space. And clue number 2 comes from a universal principle of conservation, of stuff spreading out. So, you know what time it is? Let's put them together.
Okay, get ready. This is the moment where all just clicks into place. On one side, we have our special geometry. On the other side, we have this universal spreading out principle.
So let's lay it out. Here are our 2 pillars. Clue number 1, from our geometric model, the radius of any shell n is proportional to the square root of n. Got it. Clue number 2, from simple conservation, the density of anything spreading out in a sphere has to be proportional to 1 over the radius squared. I think you can probably see where this is headed.
So, the big question is, what happens when we take that universal 1 over r squared rule and we apply it not to just empty continuous space, but to our very specific layered onion-like shell geometry? And here it is, the big reveal. So, the density at any given shell has to be proportional to 1 over that shell's radius squared. Okay. But, and this is the key, we know from our geometry that the radius is proportional to the square root of the shell number n. So what happens when you square the radius? Well, you're squaring a square root. They just cancel each other out. And what are you left with? Just 1 over n. So what this means is that a 1 over r squared law in our continuous world is exactly the same as a simple 1 over n law in this geometric shell-based world. And that's why the author of the paper says the inverse square law just emerges as a structural consequence. See, it's not some magic rule that forces have to obey. It's just an echo, a side effect of the underlying geometric framework. It has to be this way, simply because that's how space itself is built. So this really makes you think, doesn't it? Maybe we've been looking at physics completely backwards all this time. Maybe the most fundamental laws of the universe aren't really laws at all. Maybe they're just shadows cast by a much deeper hidden geometry. And that leaves us with a pretty profound question to chew on. If something as basic as the law of gravity is written into the very code of space, what other secrets are hiding in there with it?